Let me go to the cloud. And now we can start. So welcome everybody. Very happy to have you here today. Our event today, it is both recorded and live broadcasted on our channel on YouTube. And we have today with us Eddie Gavriloae. Maybe some of you know him already. He seems to be very popular in this universe of specialists in cloud. And he is working in a very challenging team in KPMG as a senior penetration tester. I understood that he's involved in different initiatives of researches in different projects for cloud. And this for me is something, at least from the distance, this research area in academic field or in any other field sounds very sexy and very challenging. And maybe I would like to invite Eddie to speak, to share with us a couple of words about what he's going to share with us, because I'm not so specialist, and he will be in a better position to describe or to at least give us some hints. And in addition, I personally would be very curious to learn about how this research territory looks like from his own shoes. And with this, Eddie, the floor is yours. Please challenge us for the next, I guess, 40 to 50 minutes. We will have in the end a couple of minutes for any questions you might have, and I'm really inviting you to raise your questions.
Yeah, thank you, Graciela. I'm very happy to be here. Research in cloud, it's great. It's also funny. It's also, I would say, easy. It's easy in the idea that there are still a lot of things to discover and to analyze. It's funny because what people might understand from doing research and having this academic way of doing it with publishing articles and so on, it's not really like that. It's mostly seeing an issue, being curious and finding more about it. But yeah, in the end, it is a form of research, and it's great, at least for me, because I can see how it brings value, both for me personally as a way of having fun, but also a way of helping others to secure their environment. So it's something meaningful, and I'm glad I reached this point where I can do research in an area. And about today's topic, I will be talking about privilege escalation in AWS, a topic I really enjoy. It will be a technical presentation that will be both for offensive and defensive people. And it will be heavily focused on practical examples from my own experience, and also it will include some theoretical attacks that I haven't fully done yet. If we are ready to begin, I can share my screen.
Yes, excellent. Thank you very much.
Okay, I'm doing that now. Can you see the screen?
Yes.
Okay, awesome. So, as I said, it's about privilege escalation in AWS, and we will cover a lot of things that are from my experience. This is also a disclaimer. Maybe some of the things I will name here are not exactly what or how other people would name it, but I'll try to explain everything as we go along. And if you have questions, you can drop them in the chat, and I'll answer them at the end of the presentation. Cool. Some words about me. My name is Eduardo Gavriloae, and I'm an associate manager at KPMG Romania. But seriously, I'm more of a senior penetration tester there. My area of expertise are cloud security and web exploitation. I write article on securitycafe.ro, which is the team's unofficial blog where we are writing our research and all kinds of articles that it seems are appreciated by the local and international InfoSec community. So I hope you'll check this out. Also, I have a cat. She usually likes white hats, but from time to time I catch her doing some black hat activity. Now let's talk about the objectives for today's presentation. So we will learn about the types of privilege escalation in AWS. We will learn how to identify attack paths, how to execute them, and at the end we'll see how we can defend and mitigate these attacks from a defender's point of view. Let's set the baseline for what is privilege escalation, at least from my perspective and for today's presentation. So let's say we have two user accounts in AWS, and we compromised the Alice account. Where you will see this red skull, it means that this identity is compromised. It's ours, right? So we compromise Alice, and there's another user, Bob. Now, both Alice and Bob, they are in the same group, and they have the same level of permissions. Nothing is different. And because of this, if we move from Alice to Bob, we say that we are doing lateral movement. We are only moving to another identity that has the same permissions as us. So it's not really privilege escalation. Now, however, if Bob has an additional permission that, let's say, he can list buckets, right? Nothing fancy, but he has an additional permission from our compromised user. In this case, if we move from Alice to Bob, we can say that we did a privilege escalation because now we have more access than we did before. Another example, let's say instead of having permissions, there is a bucket that denies us permission. So we can't do something, but only our user can do that thing. And if we move from Alice to Bob, we are again doing privilege escalation because we now gain access to an additional permission that is not explicitly denied by this bucket. And a final example, let's say there is a role that can be assumed by the user Bob, but not by our user. If we move from Alice to Bob, we are saying that this is privilege escalation because from the user Bob, we can assume this role and essentially extending our level of access. So basically anything that has that gives you at least one permission, at least an action over a new resource, we can call it privilege escalation. Now, there are some types of privilege escalation in AWS. When we are all working in the same AWS account, so we are in one AWS account, and here we can have YAM privilege escalation vectors. So basically you have a set of permissions that allows you to grant yourself more permissions through YAM actions, YAM standing from identity and access management. Next, we have service exploitation. So we steal access credentials from services like Lambda functions, Elastic Kubernetes service, or EC2 instances. And we have something that I've barely started looking into it. It's called ABAC Privesc, and we'll talk more about it. But essentially, it's a way to gain access to a new set of resources and we will discuss this later more. And if we are looking from an outside perspective, we can have cross-account privilege escalation, and we will see what it happens when we compromise one AWS account and we are moving to another that might be the management account from AWS organization, and we'll see how that can be done. Good. I will not get into much detail on this one. I just wanted you to know that this is how the policy evaluation logic looks like in AWS, depending on what permissions you have, what are you trying to access. This is how AWS determines if you can do it or not. When you are doing privilege escalation, if it works, it's great, then you don't have to worry about this at all. But if something doesn't work and you feel like it should work, it would help you to consult this policy evaluation logic to try to determine where are you blocked and if you can bypass that. But you can find this and more details on the official AWS documentation page. Let's start with some classic privilege escalation. So there are 28 YAML vectors, well documented by Rhino Security Labs. This is a fantastic resource, especially if you are just starting with Privesc in AWS. In this repository, you have examples, you have the required permissions to do the attack, you have scripts for doing the attacks, and you have scripts for identifying if you can do the attack. So really great repository, very well documented. I highly recommend it. And as a summary, each vector does something like modify permissions, modifies resources to steal permissions, or it creates new resources to steal permissions. So kind of all vectors fall in these lines of actions. And we'll see some examples right now. The first example is YAML attach user policy. So this is the permission that we will have, and we will try to escalate privileges with it. Again, our user Alice that is compromised and has the attach user policy from the service YAML over all resources. So basically, this will allow Alice to attach a new policy on any user. And we can attach to our user, to Alice, we can attach the administrator access policy, which is the highest level of access you can have as a normal user. And after we are doing this, essentially now we have a second policy that is administrator access that will give us administrator level permissions in this AWS account. And if you didn't know what exactly to expect from doing Privesc in AWS, essentially it's that simple. If you have the right permission, you can run a command, gain administrator access permissions, and fully compromise the account. Let's look to another example, create access keys. So this permission will allow us to create a set of AWS access keys. And this is the user Bob. This is not compromised yet, but you can see that Bob has administrator access permissions, and this makes Bob a very good target for us. And our compromised account has the permission to create access key for any resource, meaning for any user. And running this command, we can create access keys for the user Bob, and in return we get the access key ID and the secret access key. And once we configure them, we basically have the identity of Bob, and we have the same level of permissions as Bob does, meaning administrator level access. Now, you will not always have administrator permissions, but the idea is to elevate your privileges to gain more access than you had before. And definitely this is a way of doing it. Now, another example is put group policy. So we have this group that allows EC2 run instances. So if you are in this group, you can start EC2 instances. And now we have our compromised permissions, which are yum put group policy. This will allow us to attach a policy to a group. Now we have this policy document, which basically allows any action over any resource. And we are performing this API call, put group policy. We are specifying the group dev, which is this one. And we specify the policy, which is the one above. And after this, the group will have the new policy test that allows any action over any resource. And if we are in this group, then we benefit from these permissions. If we are not in this group, it doesn't really make sense to add an administrator policy on the group because it will not help us in any way. Next, we have update assume role policy. So roles in AWS are like identities you can assume to do some things for a short period of time. And you need to have the permission to assume roles. And you also need that the assume role policy attached to the role to allow you to assume the role. So this is our compromised identity. It has the permission to update the assume role policy of any role. And next we have a role that allows only the user Bob to assume it. And as you can see, it also requires multi-factor authentication, which is not so relevant, but it's a thing that's additional in this policy. Now, what we can do, we can modify the trust role policy so that we backdoor it. So notice this is a different AWS account. So this is the legitimate one, 278, and we have another account, 259, and we specify the user root, which is not the user root, but it's actually any authenticated identity in this account. So basically anyone in this account will be able to assume this role. And we can even leave the multi-factor authentication condition because we can configure in our AWS account the 2FA. So that's not a problem. And we just run update assume role policy. We specify this document that has this policy. And next thing, we can assume that role from our external AWS account. So we have this account 259, which is from us, the hacker. And using this profile, we assume this role from the 278 AWS account. We get the access credentials. And once we configure these credentials, we basically have the permissions granted by that role, which are administrator in this case. Okay, now let's talk about the sum of all permissions. Essentially, so what I presented so far are privilege escalations that can be done using only one permission, right? But that's not always the case. There are some privilege escalation vectors that can be done combining multiple permissions. And as you noticed, if you can assume a role, then you can benefit from the permissions from that role, right? So here is an example. We have the user Alice that we compromised, and the user Alice can pass role and assume role. So basically, the user Alice will be able to grant a role to any resource, but the user Alice can also assume any role. And next we have this role that can be assumed by Alice, and it has this policy, Amazon EC2 full access. And the attack vector would look like this. We have this user Alice, and first she will assume this role. Then she will create an instance using this role. The next thing, Alice will pass a role So this role needs to already exist in the AWS account, and ideally the role will have more permissions than what Alice already has. But the step is to pass the role to the instance. And next, Alice only has to connect to the EC2 instance, which she should be able to do since she started the EC2 instance, and she can exfiltrate the access credentials from the EC2 instance, essentially gaining the same level of access as the EC2 role she passed to the instance. Now, this works well, but one thing that you might find challenging is how do you find the existing roles for passing to the EC2 instance. And there are some tools that can help you. PMapper might be the best tool because it generates an HTML report with graphical attack vectors for privilege escalation. Then you have YAM Action Hunter, which is a great tool that helps you find certain identities that can do certain operations. So it will help you completing an attack vector. Next, you have Pacu that might be the most popular AWS exploitation framework. YAM Action Hunter is integrated in Pacu, but Pacu might be a little bit overkill for doing the just previous. And next, and lastly, you have cloud splaining that is useful. It tells you what roles have what dangerous permissions, and I believe it also tells you who can assume them. So is useful. Other tools might be out there that maybe are better. These are the ones that I tried, and I can confirm they are useful. Good. Now, when I first started doing privilege escalation in AWS, I got a bit bored because, as you saw, the techniques are not so advanced. Mostly, you have to run a command, then you are admin. It's nothing crazy, right? So I included this this chapter that's about exploiting AWS services for doing privilege escalation, and it's more of a hackerish way to escalate privileges. Now, the first option would be to use SSM send command. So SSM or AWS Systems Manager is a built-in service that has this functionality of send command, or you can find it under the name run command, that allows you to execute commands as root on any EC2 instance that is pre-configured to accept commands, which is mostly any EC2 instance in a large organization. And here is an example on how you can use this functionality to escalate privileges. So we are going to exfiltrate the access credentials through the metadata API. This API is a local API that runs in every EC2 instance, and basically that's how the EC2 instance acquires the access credentials for the role it has. And if you are making a curl, an HTTP request to YAM security credentials, you will get the name of the role attached to the instance. And if you include this this role name and perform another request, then you'll get the access credential. So the nice thing for hackers, at least, is that the instance can be private. You don't need to have direct communication between your host and the EC2 instance, because the communication is done through the run command feature. And basically, it's like the ultimate hacking tool that can run root commands on private EC2 instances. And yeah, it's a very powerful feature. Now, this is how it looks in practice. essentially, the only thing you have to change from this command is the instance ID. You have to specify the document name, which is run shell script for Linux and run PowerShell script for Windows. You perform this curl request to get the role name. This will give you back a command ID. Using that command ID, you get the output, which will contain the output from curl, and it will have the name of the role. And when you add the name role and perform the same thing, getting the command ID and retrieving the output, you get the access credentials back. And with these access credentials, you basically got the same level of access as it was granted to the EC2 instance. So really simple and really powerful. You need to have some permissions to do this. You need to have SSM send command and SSM list command invocations or SSM describe command invocation. But the idea is that you can blindly try this exploit. If you know the instance ID, you don't need to know exactly if you have those permissions, because if you have them, this attack will work. I wrote a tool about it that is a little more does a little more than exfiltrating access credential. Basically, it simulates a reverse shell, but in the background, it only sends commands using SSM send command and retrieves the output. I wanted to make this tool to make my life easier when I'm explaining to the clients the risk with this functionality, which is something I encountered multiple times in our engagements. And essentially, it's easier to show the client, look, you basically have a reverse shell in your private EC2 instance than to try to explain them in detail the attack vector. So check it out if you are curious about it, and if it helps you, give me a message. It will make me happy. Another service that we can exploit is Elastic Kubernetes service. So here we have two ways of escalating privileges. One is through the metadata access. So basically, let's say we are inside the cluster and there are 3 worker nodes, and we manage to compromise a pod inside the worker node. So this is a realistic scenario because you can have a web application running inside a pod. You compromise the web application, you get, I don't know, a server-side request forgery or a reverse shell, and you have access inside that pod. The issue is that if by default, the pod shares the same role as the worker node, which is bad. And maybe shares is not the right word, but from the pod, you can access the metadata API from the worker node. And because you can do this, you can exfiltrate the access credentials from the worker node and gain either an initial foothold in the AWS account, or maybe you can get some privilege escalation if you already had some access. But it's an issue we encounter a lot, and not always the worker nodes have the least privilege permissions they need. And even if they do, you still get some access to enumerate further the environment. So really easy and really useful. Now, the second way is an attack that's a bit more complex, and I recommend you to check this article for a deep dive in it, as we will not get into much detail about it. But here's how it works, and this is based on 2 engagements where we encountered this issue. So essentially, we were inside the pod, and the attack works as it follows. You exfiltrate the access credentials from the worker node. because you can access them from the metadata API. And now you can say to the control plane of AKS, hey, I'm the worker node. And you kind of are, because you have the access keys of the worker node. So yeah, you are. And you say to the control plane that I want to impersonate a service account from another pod. And the control plane will be like, yeah, sure, here's a token. You can do it, no worries. And what we encountered 2 times was that a service account from another pod had permissions to execute commands on the other pod. So this works in the same worker node. You can impersonate any service account from the worker node. And we impersonated a service account that had this permission to execute commands in any pod. And we were able to exfiltrate a web token that we used to assume a role in AWS. So there are these roles in AWS that are working with web identities using OpenID Connect. And essentially they are like this. So they are federated, and here you can specify your AKS cluster. And here in the subject condition, basically you specify the namespace and the service account that can assume this role. This is a way to allow service accounts from the Kubernetes cluster to assume roles in AWS so that you will not have to grant the worker node the permissions required by the service account. So in theory, it's a good thing, but if I can compromise the web token required to assume this role, then I can also assume it, right? And if you have already access in a pod, you should look for environmental variables that specify the role name and specify the location of the web identity token file. It's usually in this location, and then you just have to run this command, assume role with web identity. You specify the role, which will be given by this variable. The role session name can be anything, and the web session token, I believe it has to be the value inside this file. And next you will receive access credentials for that role. So let's take a look again. We impersonate from a compromised pod. We impersonate the worker node using the worker node's identity. We talk with the control plane and we say, hey, we want to impersonate a service account from another pod from the same worker node. And next, using these permissions, you can move to other pods and assume this role from AWS with the access token. Now, if you didn't understand much of it, don't worry. I didn't either. It took me like 3, 4, 5 tries to really get a hold of it. But I highly recommend you to look into this article because it's a technique that works almost every time, because this is a design flow in AWS that allows you to do this. So make sure you are checking out when you are doing your next AKS configuration review or red team engagement. Okay, now stealing from Lambda functions. So in Lambda functions, the access credentials that will give you access to the role granted to the Lambda function are stored in environmental variables. So you have AWS access key, secret access key, and session token in environmental variables. That's all and good. Now let's say this Lambda function has an entry point that makes HTTP requests to other websites and returns the output. Now, if the function doesn't verify the schema of the request, and you can specify the file proc self environ file, you will get in response the access credentials from the Lambda function. And essentially, this will give you access to the role attached to the function. Another way is to get remote code execution on the function, but that's not so likely. But if you have a server-side request forgery or a file inclusion, then maybe you are in luck and you can read the access credentials from the self-environment file. Now, another way to escalate privileges is to hack bad implementations. So you can look toward API gateways or some automations with Lambda functions. And what we actually saw in one engagement was an API gateway that was configured poorly. It has this. It had this resource based policy that basically allows the API gateway to be invoked from any VPC, even if the API gateway is private. If you have this resource-based policy, you can access, or better said, you can invoke the API from external VPCs. A private API gateway in AWS is private in the sense that it can't be accessed from the internet, but only from the internal AWS network. But this also includes any VPC from any other AWS account, right? So we had this misconfiguration, and what we are able to do from our own AWS account, we configured an EC2 instance in the same region as the target API gateway. We configured a VPC endpoint, and essentially we were able to invoke the API gateway because it didn't have any authentication. It was the client thought that being private means that it can be only invoked from their AWS account, and from an EC2 instance in an external AWS account, we managed to invoke the API, and this API was configured in such a way that in certain endpoints, the API would invoke Lambda functions or read and write files from certain S3 buckets. So basically, we gained access to invoking Lambda functions and reading and writing files to certain S3 buckets from an external AWS account. It's true that you still had to know what endpoints and what parameters to give in order for this to work, but maybe that's some information you can get from an information disclosure vulnerability or something like that. And what is certain is that security by obscurity is not a way of securing your cloud environment. So really cool attack. I recommend you to read more about it if you didn't know it, if you didn't know about it. Now, let's talk about ABAC privilege escalation. So ABAC stands from attribute-based access control. So maybe you've heard about AirBAC, which is role-based access control. There is this thing in AWS, and I'm sure in other cloud providers too, where you can manage access to certain resources based on tags. And here's an example. We have this in the same AWS account. You have a small organization, and you have front end, back end, and database in the same AWS account, and you want to make a single policy that would work for any EC2, any YAM user, so that it would be something like this. If the user has the team, the tag team with the value front end, then that user can operate over resources that has the tag team with the value front end, right? So that's basically it. And from what I've heard, people are using this. This is the theoretical scenario that I've never encountered in practice, but maybe it's something to look for, because here is what can happen. So you have a backend developer that can modify Lambda function. So this backend developer has the team tag set to backend. That is fine, but he can modify this Lambda function that has the permission to tag add other resources, and that's where the issue comes in place, or better said, the attack vector. So you can invoke the function and say, hey, modify the tag from my user from backend to be database, and the Lambda function has the permission to do that. It does, and next, based on the permission that applies to every user in the account, you can access the data from the database. So basically, that's it. It's not such it's not a crazy attack vector. It's something I've never encountered in practice, but I'm sure somewhere around this world, this scenario can be put in practice, and defenders should be aware that this can happen, and they should check if the backend developers in specific can invoke functions with permissions to modify text. So this was it. Now let's talk about cross-account privilege escalation. While it sounds kind of fancy, it's nothing magic. And here is an example. So we have this role called auditor that is in this AWS account with 278. And this role allows any user from another AWS account to assume it. And here's where the issue comes. This is called the confused deputy attack. We have from the other AWS account a user named AI engineer, and this user can assume any role. That's the permissions this user has. And because the user can assume any role, he can also assume this role, especially because the trust policy of the role allows him to do it. And basically that's the whole issue. When you are allowing any user from another AWS account to assume this role, and by the way, this is something we are seeing a lot. There are a lot of cross-account access granted. If you have this kind of users with the permission to assume any role, you can have an AI engineer that assumes the auditor role, even if the AI engineer has nothing to do with this role. And this way, if someone compromises the AI engineer user, they will be able, if they know about this role, they will be able to assume it. So something to keep an eye on. And if you manage to get inside on a management AWS account, you can do much. Like it's not like compromising the domain controller, but you can definitely cause some chaos. Maybe you can delete some accounts. Maybe you can create new accounts. Also, you can modify the service control policies, which are controlling or better said, they are limiting the access granted across the whole accounts from the organization. So maybe you can change a policy so that defenders can't check your activity, or maybe you are removing some deny statements from your user, and so on. Again, you can grant yourself more access by specifying allow statements, but you can make sure that maybe defenders are having a hard time finding your activity, or you are removing some limitations that are put in your over your compromised use. Now, my take on privilege escalation is depending on the type of engagement. If you are doing a red team or an insider threat engagement, the short story is that you should attack. Um, your results are based on attacks that worked, right? So you have to determine your permissions and build an attack path. So you are starting from an identity, a compromised identity. Maybe you don't know exactly what it has, and you should look for a misconfiguration that you can exploit. Now, if you are doing a cloud configuration review, your job is not exactly to attack. You can formulate some hypothetical scenarios, and those scenarios would be valid findings. So you have to find I mean, the easiest way is to find misconfigured resources and then look for attack path. So you see a misconfigured role, and now you are looking who can assume this role, and you can say in the end, hey, if this user is compromised, the attacker will assume this role and will perform privilege escalation. So right, so you don't have to actually compromise that user to demonstrate the attack. You just have to write it down. So you are starting from misconfiguration, and you are going towards an identity that can enable the whole attack chain. Okay, some let's say steps or a short methodology on how it makes sense for me to look for privilege escalation. First, I enumerate permission if I can, meaning that if I have the permission to check my permissions, I'm doing it. If yes, that's cool. If not, I can blindly try things. But the second thing I will look for is for one permission YAML privilege escalation vectors, like attaching the administrator policy to myself, or attaching a policy to a group that I'm part of, and so on. If I don't find anything, I'm looking for roles that I can assume, and then I repeat the step 2. So now I'm checking if the roles that I can assume have one permission YAML privilege escalation vectors. If not, I'm looking for the combined permissions from my identity and from the roles that I can assume. So I'm checking if I can combine a permission from one role and another role to build a complete privilege escalation vector. If nothing works, I'm looking for exploiting services. My first place to look is Lambda functions, because maybe I can read the code and maybe I can invoke them, and they are usually more friendly with being attacked. Whereas EC2 and AKS, you actually have to be inside of them to do something, right? So you need to compromise them. Another options are the API gateways that maybe you can assume from anywhere, but that would be it. Yeah, so this is how I'm doing it. So I'm trying to find permissions, finding low-hanging fruits for privilege escalation. I'm looking to extend to get the full picture of what permissions I do have. And if nothing works, I'm looking for exploiting services. But that's the last thing I check, because that might be the hardest and most unlikely place to be able to exfiltrate access credentials. Now, I have, I think, another 2 examples from for previous from engagement. We identified in one engagement a role that had administrator access permissions, and we checked who can assume this role. And basically, this role can be passed to 7 services, and this is a bad thing, because it increases the chances you will have a privilege escalation vector in your account. So now all you need is a user that can create an EC2 a Lambda function, a cloud formation, and anything that has privilege escalation in it. The user needs to create a resource and pass this role to that resource. And basically that's it. You have a privilege escalation to administrator, and after the resource is created and the role is passed, the attacker can exfiltrate the access credentials from that service. And usually this type of thing is not recommended. So you shouldn't grant administrator access to a role. You should follow least privilege principle. And you should also not create a role for 7 different services when those services, I'm sure they have different requirements for doing their job. And another example, so we identified a role with this trust policy. So the role was assumable from a different AWS account, but you had to know the external ID. This is like a password, but it's not that confidential. It's exactly the mitigation for the confused deputy attack, right? So now, even if we have a user in this AWS account that can assume any role, if that user will not know the external ID, he will not be able to assume, right? So it's a mitigation for that. Anyway, we had this account that had permissions, that had administrator access on it. And we found another role that was assumable by anyone from the internet. Now, when I say assumable by anyone on the internet, I mean it. So basically from any AWS account, if you know the ARN for this role, you can assume it. And funny enough, this role had the permissions to find out the external ID of this role. So even if we had read permissions and we already compromised an account that could have assumed this role, we wanted to show that it's possible without having read permissions or having our level of access to escalate privileges. And in our luck, it was this role with something like test developer name. And these are the funniest roles we usually find that have test in them and some name of one developer. They are forever left there. And we assumed this role. We found out the external ID, and this way we were able to assume from our already compromised user this role and gain administrator in this AWS account. Cool. And other things that we found, and you can take a look into it, is hack the environment's automation logic. And you should take a special, you should especially look towards Lambda functions. We had a case where a Lambda function was taking events generated by an external API, and the events were processed automatically. And looking through the code, we determined that inside the Lambda function, there is external XML XXE, external XML injection that could have been used to exfiltrate the access credentials from the environmental variables by reading the proc self environ file. So these are some more complex and hard attacks to perform. But if you are doing a cloud configuration review, it's enough to put them on the table and say that this might be possible. Here's how it would happen. Can we verify it or not? But you should definitely report it. Okay, now something that you might find yourself in if you are doing a red team is enumeration in the dark. So you don't have the global read permissions to check what permissions and what can be attacked. And there are a few tools for doing this kind of enumeration. The first one is enumerate YAM. This tool, or better said script, will check every read API call from AWS, and if something works, it will tell you that you have the permission to do that thing. So very, very cool thing. It doesn't check for write permissions, and when you are doing privilege escalation, you should know what write permissions you have in order to actually perform the attack. So there's another tool called CloudTrail to YAM, which requires permission to read CloudTrail logs. And basically the tool will analyze the logs and will determine what operations you can do based on what your user already done. So you've done something, it was logged. This tool will look inside the logs and it will say, hey, this user did this, you might be able to still do it. So obviously the permission might have changed in the meantime, but it's a really cool and smart way of determining write permissions and even read permissions without even enumerating the environment. And you also have Pacu that can even run AWS Privesk vectors, and if they work, they work. If they don't, they don't. You can try them blindly. It also has modules for doing enumeration, for brute forcing roles, and much more. If you, I have to say, I'm not using Pacu almost at all, but it has some nice features, and it's definitely worth looking into it. And of course, you have AWS CLI, which might be the best tool, especially in the beginning when you want to understand better how AWS works, what is happening, what API calls are doing what. And you can just try this with AWS CLI and learn something in the meantime. I actually took every API call from the AWS CLI and tried out for an article I wrote, so that I can identify what API calls can be used to perform relevant enumeration. So, and I learned a lot doing this. So yeah, I actually recommend it. Okay. Now some tips. Don't use a well-known hacking operating system like Kali Linux, because this will generate an alert in guard duty. Guard duty is a service in AWS that tries to identify threats, and when you are using Kali Linux, guard duty will generate an alert with this activity, and it's actually a bit funny because the clients usually are emailing us, hey, this you guys, we got an alert in guard duty, and the alert is just that we are using Kali Linux, and we know that, but what the client doesn't know is that you are already half away from fully compromising their environment, and guard duty only tells them that we are using Kali Linux. But as funny as that may be, if you are in a red team and you plan to be stealthy, don't use Kali Linux. Use Windows works well, Ubuntu as well. Essentially anything that is not specifically designed for hacking. Another tip: if you already have an initial access, you should keep generating new sessions. You can use this API call, get session token, and you can specify a duration of 36 hours. This is useful because if you are caught, so the defenders, they see you compromise an account and you are doing some things. If you have a session generated and the defenders don't know exactly how to prevent your access, you can still have 30 plus hours of access in that environment, because it works like this. Let's say the defenders, they they see your activity, and the first thing they do, they delete your access keys. So the access keys are not working anymore, but you have the session generated, and you use the access credentials from the session. And because of this, you still have access in the environment. The right way to cut off access of an attacker is to put an explicit deny on that user and then deactivate the access keys. And I say deactivate because you might not want to remove evidence from an incident response flow. But in any case, if you are an attacker in a red team scenario, make sure to generate these sessions I don't know, from hour to hour to make sure you have an extra chance of keeping your access for at least 30 hours in that environment, which is actually a lot. Yeah. Another cool thing, but we will not get into much detail about it, is a research done by Nick Frischet that is about evading logging. Basically, he saw some staging and production number 2 APIs from AWS. And he noticed that even if the APIs are not the official production APIs, they are connected to the production data. So basically, you communicate giving your credentials, of course, with the staging and secondary production APIs. You get the information about what's inside the environment, but the calls to those APIs is not logged in CloudTrail. So most of them, from what I understood, are fixed and patched, but I'm sure there are other things. And if you're serious about being stealthy, maybe this is something you can take a look into. Good. One thing that I don't like when talking about hacking the cloud is you don't have initial access, right? And that's the biggest pain. And all of the attacks are from the already compromised scenario. I'm here to tell you that there are still ways to get an initial access in an AWS account, or even doing privilege escalation without having an initial foothold in in that account. And one way of doing it is exploiting public resources, and this is the latest research I've done in collaboration with Matei Josephs. Basically, we searched for secrets in public AMIs. We wrote an article about it. Now, a little disclaimer, we got accepted to DEF CON with this talk, and because of that, we had to redact the article so that you can see it let's say firsthand at DEF CON, but we'll make it available again after the conference. But what we saw, the one result from this research was that we gained access in over 120 AWS accounts from exposed AWS access keys, and between and across these API access keys, 20 of them were from the root account, which essentially means full permissions over the AWS account. It's the highest level of permissions you can have. It's even above a normal user that has administrator access. So exploiting public resources, that's a way to gain initial access in one AWS account. And in some cases, you can even gain administrator level access from the start. So maybe some people would not call this privilege escalation, but in a sense, you start from nothing and all of a sudden you have access to one account. So we can argue that this is privilege escalation, or at least it will give you a chance to start the privilege escalation process from that point. Now, let's take a look at the demo, and next we'll talk about defending, and that would be it. This demo is about something I've discovered recently, and I wanted to be my next research, but I've talked with the AWS security team, and they don't want me to do it. But essentially, is a way of getting administrator access permissions from the internet without having the initial access in the AWS account, and it has as root cause a default from AWS. So if you want to create a Terraform role using the OpenID Connect, you will notice, and of course we have to put the administrator access because it's Terraform, and Terraform should be able to do anything. This is something that we already encountered in practice. And essentially you can see here that we only have the audience condition, right? So this is the point of view of the defender. And if you remember the web identity role from the AKS example, that role also had the subject condition. And here we don't have the subject, we only have the audience. So when I first saw this, I asked myself, does this mean that anyone can assume the role? And it turns out that is the case. So here is the point of view of the attacker, and we are in Terraform Cloud, and we will configure two things. So we have to specify that the AWS provider auth is true. And next, and this is the only thing we have to know, is the ARN of the target role. So basically, if you know the account ID together with the name of the role, you essentially can assume it and perform actions using Terraform. And here is a proof of concept script. This script will create a new role, and it will be backdoored so that it will be assumed from an external AWS account. And of course, we want this role to have the administrator access permission to it. Now we run Terraform. In the background, Terraform will communicate with Terraform Cloud. It will assume the role, and it will, as you can see, it already checked what will the modification be, and it will create the role, and it will assume, it will attach the policy administrator access. We say yes, that is fine, and now we have this profile from our hacker that is from 944 AWS account, and we can just assume the role we just created from a different AWS account. We get the access credentials, and now we just configure the access keys we got, and we basically will have administrator access permissions in that AWS account. We'll make another call just to show the difference. So we have this hacker profile that is from a different AWS account, and now we have the new role that is called that is stored in the profile backdoor, and we have the identity of this role. So basically, this is a way of escalating privileges from 0 to administrator access. It involves Terraform. My research idea was to collect as many AWS IDs as I can, and try to check to assume this role using different role names like Terraform OpenID Connect, Terraform OpenID Test, or just Terraform, and see what it comes out. Because if one customer has this issue, I'm sure others will have too. but AWS security team said I shouldn't do this because that's not public resources, and they also don't really plan on modifying the default behavior that can lead to this issue. But I'm still discussing with them, and I hope they will come around and they will do something about it. Okay, let's talk about mitigations. So the biggest mitigation you can and should put in place is to apply least privilege principle. And for this, you have a few options, but I think the best one is to use YAM access analyzer. Now, actually, the best option would be to, when you are creating the resource, to start from a minimum set of permissions and attach new permissions as you see that they are needed, right? But if you already have permissions granted and you want to reduce the number of permissions, you can use YAM access analyzer. And this is something from a real engagement. So we noticed a user that had administrator access permissions, and I wanted to take a look if indeed this user needed administrator permissions. And this is access advisor. So basically it tells you what services were accessed and when was the last time. It has a limited time for logging this API calls, but as you can see in the bottom, it worked for the last for over 1 year ago. So basically, this user, even if he had administrator access, he only accessed these services, right? Service quotas and the ones above. Even if they did a lot of API calls from these services, that's still a small list of services compared with the full list, which is 366 services, right? So that's a good way to check what your role actually needs, how often it uses it, and based on this, you can generate granular permissions. And I'm sure there are tools that can do this. And maybe there is something already built in AWS that can do it, but honestly, I haven't checked it yet. But definitely, Access Advisor is a good way to start. Now, service control policies and duty segregation. So some service control policies that you might want to put inside your organization is to deny access to any service except a list of pre-approved services. And keep in mind that you can apply these service control policies either on every AWS account or only on specific accounts or on specific organizational units. So you can control what services can be used. You can prevent the root user from being used. You can enforce AMI for certain sensitive operations. You can deny access to certain regions. And if you are using a single region, this will make your life easier. So because you don't have to monitor and analyze what is happening in every AWS region. You can deny deletion of CloudTrail loads because that's definitely something that you don't want and it should be prevented. And you can limit the creation of YAM resources so that maybe only the security team can create new YAM users, roles, and so on, since this area is the main area that can give you privilege escalations. And about duty segregation, you can grant different roles or groups or permissions depending on what that user is doing. So developers might not need permissions to create YAM resources. Database engineers might not need access to Lambda functions and so on. Duty segregation is important and can help you in mitigating an initial access that happens in your environment. Now, a good architecture can definitely help you mitigating the impact of a breach. The best way to do it is to separate AWS accounts per environment and solution. So let's look at this diagram. We are in an AWS organization with multiple accounts, and you should have separate accounts for at least YAM access, billing, security, infrastructure, shared services, and logging. Maybe logging, YAM access, and security are the most important ones. And the reason for that is, let's say you have an organizational an organizational unit one with a certain web application, and let's say that that web application is compromised, the user fully compromised this account. Well, even if the account is compromised, other solution will not be impacted, logs will not be deleted, security monitoring and logging, it will not be impacted, and also YAM access, it will not be modified if the architecture is done properly, right? And when you are using a dedicated YAM access account, basically any employee can log in in a portal deployed in this account, assume a role, and then access specific resources. And this way you have a central place for managing and controlling who can access what account, maybe multiple accounts, and so on. Now, shared services and infrastructure are good for if you have some I don't know automation in place, or some things that you know they will be available in any AWS account. You can specify, you can create them in dedicated accounts and make them available for every solution. And regarding solutions, when I'm saying solutions, so if your organization creates a new web application, then it's better to have that web application in a separate AWS account. And maybe for small companies, this doesn't make a lot of sense, although it would help you. But for big organization, I would say this is a must. And we are also seeing in clients with a certain degree of maturity that this is the only way they operate, and it works really well. Now, if we are looking on a solution, on an organizational unit, if you have multiple environments, then you should have separate AWS accounts. So you should have separate accounts for dev, stage, and prod. I've seen some people combining dev, stage, and pre-prod in the same AWS account, and that made it very hard to review it. So we had to do a configuration review on that account, and we actually had issues with how many resources were out there, because it was also dev, also stage, also pre-prod. And again, if something gets compromised, or if it's made publicly available, then of course all the resources are compromised, and you don't want that. And definitely you don't want developers having access in your production account, and you don't want you don't want dev resources that maybe are vulnerable to be running in the same account with the production application. So this way allows you to mitigate risk, and also it allows you to better control the accounts, and you can even delete the accounts, the dev and stage accounts, once the production is complete. Good. Now you should also do periodic YAM reviews, because the requirements and permissions from your environment might change, and you might find something new to improve. And you should also do cloud configuration review regularly, as it helps you gain a third-party perspective on what attacks are possible in your account, and what other hardening configuration you can implement. Some final thoughts. So for defenders, I would say to regularly review your YAM resources and implement automation for incidents, so that if something is detected, and you don't want to spend time trying to access that resource, trying to delete it, maybe making mistakes. No, you want automation, and you want a Lambda function to cut off the access properly to that resource, and then start other automations, maybe isolation and so on. And for hackers, if you have a complex environment, most likely you will have a pre-risk vector. You just have to find the way to exploit it. If you are doing configuration review, you can do it with or without execution or pre-risk escalation. But if you are doing a red team, you should have execution of the pre-risk in order to show the risk. And also you should have in mind this aspect of stealth. And as a last tip, I would say hack legally, of course. The cloud while is still easy because I think defenders are catching on. Now, thank you. If you have any question, feel free to drop them in chat. Or do we already have questions?
Eddie, thank you very much for the presentation. It was just a bit longer than expected, but full of I would say very important information. Important if somebody probably is very passionate or curious, or in terms of guidance, I would find, I don't know, at least 20 topics to search for after this meeting. I would invite anybody to raise the questions if you have any. And meanwhile, until the participants will decide to to address their questions, from my side, I would say I am impressed and concerned in the same time by the relaxation and easiness with which you are presenting, this entire story from the distance, from outside. It doesn't look complicated. It's like you need to have the knowledge. Okay, the experience might come in time, probably after you'll get bored, as you already mentioned it, but doesn't look complicated. It is the same feeling at your end.
Yes. Obviously, when you have also experience, so we are talking about someone else's environment and you don't want to ruin things. So that's the stressing part of it. But once you know how you can break or not something, you only have to have the knowledge of the attacks. And once you get a feeling of how things are done in cloud, you just have to be good at reading documentation, because that's mostly it. It's not like you can, I mean, in most cases, it's not like you can access hidden features from AWS. No, you just have to see how things works, have that offensive mindset, and yeah, identify the issue, the attack path, and maybe in some cases extrapolate it and do something like a mass exploitation. And this is another topic that should be in everyone's attention. You can be hacked without being targeted, and that definitely sucks. And it's possible, and we are seeing it. And I'm starting to identify multiple ways of compromising random AWS accounts without knowing who owns them. And for, let's say, ransomware groups, they don't really have to know their target that well before compromising the account, and maybe then finding out who they compromised and if they decide to act on. So yeah, it can be easy once you start reading the documentation and getting a feeling of how the cloud works. It becomes easy.
Okay, so from my side, it is true. It might be impressive and concerning in the same time. You mentioned, of course, the last part of the presentation was focused on what the organizations can do. I have many questions here. I will start, or I will select a couple of them, but I will start with, you said the first thing to do is to, run an exercise to identify the misconfiguration. And you presented or you shared a couple of, for example, the tool for identity and access management for AWS. But I'm not being a specialist. I'm not sure whether this is dedicated for AWS or this is you can find similar tools for other types of clouds. But the general question might be where to start from. Okay, identity and access management might be only a piece from whatever cloud configuration, security configuration means. Would you have, I don't know, a best practice to recommend to start from?
So the best thing you can do is when you are creating new resources that need permissions inside your cloud environment, grant them the minimum permissions you are aware they need. So as granular as possible. And when you see that things are not working, you just add that missing permission. This is the best way to do it. Now, if you already have the resources, you should analyze if the permissions are indeed used and what is not used to be removed. And I want to add something here that I forgot to mention. Let's say you have some automation with a Lambda function that rotates access keys, right? So the Lambda function has the permission to create access keys for any user, which in essence is a privilege escalation vector. However, if you control who can access and invoke that Lambda function, that is completely fine. Like you don't have to eliminate everything that is privilege escalation from your environment just because there is this risk. No, the permissions are there because they are useful. But what you need to do is to control who can access the resources with high permission. So I would say three things to answer your question. First off, if you are creating new resources, start from the most granular possible point and add permissions as you go. If you already have the permission created, check what permissions are used and remove anything else. And if you have resources with high permissions, make sure you control who can access or limit the access to those resources only for the persons that you know they should access them.
Sounds easy, or not really.
In theory, yeah.
In theory, yes. Because I'm not very familiar with probably some relevant details. Any particular reason for building your research and your presentation on AWS?
So even if cloud is cloud, and you can say that similar services are doing kind of the same thing in AWS, Azure, and GCP. It's actually a whole different domain of expertise jumping from AWS to Azure and GCP. Now, most of my experience is with AWS, and that's also the type of engagements we most often get. So it made the most sense for me to talk about AWS because I had the opportunity to include practical and real examples and also talk from my personal experience on these things.
Okay, thank you. Any other questions from the audience?
Well, if not, they can always find me on LinkedIn or Twitter, and we can chat more about it. I guess if they would have had some questions, they would be already in the chat. But if you want, we can wait a few minutes more.
Let's try a final question, and let's see whether something new appears. I'm curious about the way you perceive the organizations or the reaction of the organizations where you run different projects. Let's assume you are invited to, I don't know, run a penetration test or perform some checks, or actually the outcome might be exactly this identification of misconfiguration, might be a potential, let's say, scope of work.
Yeah.
And I'm wondering about your perception on how do you find the level of awareness or the level of familiarity of the specialists within the organization related to the result. Are they surprised? Are they familiar? Do they, I don't know, it's a personal
No.
opinion.
So yeah, it's a bit funny because the defenders or cloud engineers, they are still missing that offensive mindset, and that's why you're doing a cloud configuration review with a third party that has this mindset brings value. However, the defenders and engineers, they are well not aware, but they have the knowledge, and they know once I put it on the table and I say to them, hey, this is the issue, they instantly understand it, right? So having this white box approach where we can view all the all the resources doesn't leave much room for interpretation. Like the issue is there, and this is it. The defenders are not necessarily surprised, but they have like an aha moment when we present them. Some of them, they said to some findings that they didn't know about this issue, how it can be a security misconfiguration. But in most cases, defenders are happy to learn something new and better protect their environment. So they are understanding the issue. They are just not. They just didn't see it from an offensive perspective when they added it in the environment.
Nice. So it is about playing different roles. That would be helpful for any engineer.
Yeah.
Good. Thank you very, very much for the presentation. I enjoyed, I fully enjoyed, and hopefully all the participants did similarly. You are available on LinkedIn. You kept your details for how to be contacted several minutes. Hopefully you will get direct questions if possible. Otherwise, from my side and Cloud Security Alliance team, I thank you very much for your time, and yeah, keep in touch. I will follow you.
Thanks as well for having me and for the follow.
Good.
Have a good day,
Good
everyone.
evening. Bye.
Bye bye.